Previous speakers, particularly Professor Mukherjee, has already explained the basics of this 5G, the enabling technology for this IoT and this future days mobile communication technology. He has made my life pretty easy. And also the previous speaker, Dr. Bhatnagar, has talked a lot, has given you a broad overview of the different practical aspects of this Internet of Things. A lot of questions have been asked by all of you. And it is very exciting for me to see here from the dash that how the audience actually interacted and they actually made themselves at one with this new technology of the future, which is coming pretty soon. Basically, since Dr. Bhatnagar has addressed mainly this Internet of Things, I will try to go something deeper, some aspects of this enabling technology 5G. Professor Mukherjee has already told you that there has been an evolution in this communication technology, mobile communication or the voice communication technology from 1G to 4G in the form of, say, initially 1G was just for the voice, analog signals, then we went to the digital domain, voice and data came in, and so 2G, 3G, 4G, everything came. And basically, what we want to do that there has been a speed increase. As you can see that starting from very low speed, say 2G was only 64 kbps, and now in 3G we are doing with, say, 2 Mbps, and 4G with, say, 100 Mbps, and possibly want to go more. So what was the problem with the 4G? So 4G, we already had this high-speed data access, and that is we have this high-quality streaming video requirement. That is a combination of this Wi-Fi and WiMAX. This is capable of providing 100 Mbps to about 1 Gbps speed. And usually we call that this 4G technology satisfies something like, say, magic. Magic means same as mobile multimedia, anytime, anywhere, global mobility support, integrated wireless solution, and customized personal services. So this is also known as the mobile broadband everywhere. But these major drawbacks, what people felt with this 4G, that this data rate was still insufficient because of the huge requirement of this from the users. There has been an explosion in the number of the mobile users over the last few years. And there is also the problem with the 4G is the high battery drainage. Even my mobile has to be charged, I think, twice every day. This is very much annoying. And often this involves some expensive and complicated equipment which is required to be implemented for the next generation networks. So just as a solution to this 5G has been proposed, or this is being envisaged. And as already pointed out by Dr. Bhatnagar, that this is expected to come in around 2020, okay? So what are the, this reason for this 5G are these following. As you can see from this slide, there has been enormous uptake in the use of the mobile broadband. We need high-speed multimedia data communication, just not the voice. We send, not the voice, not the text message through, as we do through SMS, but also we send still images, we do some video signals, and also we do have some teleconferencing like that. And in all these multimedia communication, we want to have the desired quality of service. The quality of service involves so many things. For the experts particularly, they know that we want to have, say, delay is, propagation delay, this is one of the requirements. Delay jitter, variation in the delay, that is also another requirement. We want to have reliability. Well, say if you have the voice or video communication, then so voice communication delay can be a very important thing. I'm not going to elaborate on those things. Even the video communication, voice or video, the delay and delay jitter are the very important parameters. But if you consider, say, text communication, the delay and delay jitter cannot be that important, but reliability is all the more important. You cannot lose a single bit so that your text is actually completely wrong. You get a wrong text. On the other hand, if you deal with just voice or video, you just don't listen to one particular part of the sentence talked by the other partner of your conversation, you can ask him again to repeat it. So that's bad, but it's not that bad, okay? On the other hand, there's other kind of quality of service requirements from the service providers as well. I'm just cutting all these things in short. And there is an expected increase in the traffic volume by 15 times during 2016 to 17. There's a massive growth as for the IoT. There's 5 billion wirelessly connected mobile devices, for example, handheld terminals, portable computers. And Professor Mukherjee has already told that we expect that 30 billion such devices will be there, which will be connected all together. And there are some human-centric connected devices as well. The surveillance cameras, smart homes, smart grid devices, connected sensors like that. So these are the requirements. And there is also another types of requirements of this 5G for the safety of the control mechanism, say power grid or the remote meter reading, remote surveillance, cargo tracking, whatnot. And in all these different types of applications for our social life, this society of tomorrow, we want to have certain requirements. The latency must be very low. For example, if it is a power grid application, then latency must be very low. If it is a power grid application, we also have high reliability, and it should be able to handle a large volume of data, as we know, as we may need for the remote surveillance cameras. And at the same time, Dr. Bhatnagar has already pointed out that our battery power, that should be drained as minimum as possible so that we can continue with a specific battery set for as long time as possible, maybe for say 10 years, like that. And the cost for deployment of such batteries and the devices for operating all those devices and maintenance, that should be as minimum as possible. So basically, the requirements can be summarized as this. The data rate is say 1 to 10 gigabits per second. Data volume may be say 9 gigabit per hour in busy period, or 500 gigabit per month per subscriber. Latency should be less than 5 milliseconds. Battery life should be preferably 1 decade. Connected devices maybe say 3 billion devices, or maybe say 30 billion, we can go like that. And reliability should be as close to the 100% as possible. So the main problem is that to cater these services, what are the problems before the technologists or the scientists? Basically, the bandwidth is the main problem. Even with the 4G, we often experience severe call drop at the busy hours. Even say in this hall, if there are say 1,000 people, and if maybe at a time 1/10 of those people start talking at the same time, then there will be huge requirement of this bandwidth. But with the 5G, what we can do, that we actually move the spectrum to this millimetric wavelength, as you can see from this slide, that instead of this usual say 800 megahertz to 900 megahertz band or the 2.4 gigahertz band, we are going to say 28 gigahertz, 38 gigahertz, 60 gigahertz, or 70 to 90 gigahertz in those ranges, and we can actually exploit those millimetric wave range for catering these services to the 5G users. So basically, if we want to do that, allocate the channels, then of course we have to have certain technology, something to be devised. So, because when there will be a large number of users, so there will be one access point here. Professor Mukherjee already told you about the classification, the subdivision of the things. One is DU and the RU, so radio unit. So in the radio unit, so there will be one access point, and to that access point, there will be say hundreds of such users will be connected, and all those 100 users should be provided some specific channels so that they can all start talking together. So the problem will be allocating the channels and avoiding the interference among the different users, reusing the channels in different small cells, and all these things must be done pretty fast, okay? And the latency should be as small as possible. When you want to allocate the channels, that channel allocation should be done very fast. Energy consumption should be as small as possible. So these are the requirements. And moreover, the problems with the 5G, when we will have these small size cells, there will be frequent handoffs. Okay, so the handoffs, well, one technique is through this RU and U classification, but that has to be properly thought up in the coming years. So, and on the top of it, so basically the channel allocation is one of the research problems. Management of the handoffs, that is another problem. And then energy efficient communication at all levels, at the physical layer, from the physical layer starting to the physical layer to the MAC layer, to the network layer, to the application layer, everywhere we have to have these all possible channels or avenues for energy efficient communication that should be explored. And on the top of that, the secure communication. Security is very important, particularly when you go to IoT. So naturally, my refrigerator must not be controlled by somebody else, okay? So it should understand that it is me only, and that signal should be able to actuate that particular refrigerator. So like that, the security is also an important aspect, and that should be totally, overhauled. This whole concepts of this secure communication should be totally overhauled, because speed is one important thing. We can have possibly very high, complex encryption mechanism, decryption mechanism, but that will not work here, because we want to have all those pretty fast. The other encryption, decryption algorithms which are very complicated and complex, that will require more time. So we cannot really afford a lot of time. Well, this part of this lecture is just for, since we have got this wide variety of this audience, for everybody. I think everybody could get all these ideas. Just for the other people who are working in this field, I would like to address one particular issue, that is channel allocation part. Basically, if you want to do this channel allocation, I think I have got 5 minutes. Okay, in 5 minutes, I think I will finish it. So if you want to do this channel allocation business in this 5G environment, then normally it is recommended that, or it is envisaged that the cognitive radio network concept that will be useful for providing channels very efficiently, effectively, and in a, within a very small time to all the 5G mobile users. So just, one thing I can say that even by the Indian scientists here, okay, we have got made use of this concept of this cognitive radio to allocate the channels which will be useful for these 5G users in the future, and that has been based on very simple concept. So what is a cognitive radio? Just I am telling you that the cognitive radio concept was given by Mitola a few years back. He said that while most of the users band, total available band is actually divided into two classes. One is a licensed band, another is an unlicensed band. Licensed band is owned by some users, they pay for it, whereas the unlicensed users, they do not pay for this band, but they can use anywhere, any part of the band, provided that is free. So the licensed users are given the name as the primary users, and the unlicensed users are called the secondary users. So his concept was that, if we have some kind of, say, software-defined radio, where we can program this transmission channel, and we can sense, we have this cognition capability that we can sense that which part of this channel is currently free. And then we can use that channel for every secondary user can be allocated that channel. But as soon as, even if that is a licensed part, licensed band, and if it is free, that can be used by an unlicensed user, that is a secondary user. But as soon as the actual owner of that band comes in, then that band should be deallocated from the secondary user, and it should be made available readily to the primary user. So this is basically the concept. So the concept is pretty good, and it has been implemented in practice. So it requires some kind of programmability. So the transmission frequency or the reception frequency, that should be programmed to the software. It should have the cognition ability. So the devices must be able to understand which part of the band is being used by which user, and it should have also the reconfiguration ability. So these are the three requirements for reconfigurable depending on the status of the channel, the noise around, like that. I'm not going into all these details, But using this particular thing, there has been one. So basically, this is a diagrammatic representation of this cognitive radio network. And this channel assignment in a cognitive radio network may broadly be divided into two sub-problems. One is this channel sensing, and another is channel allocation. The good thing about the research which is being done in India here, actually in my institute, that we can, suppose we have got a, say a few channels. Suppose I just look at this example. So there are several channels which are available, as you can see, which are these white channels which are available, and all others are actually, the shaded channels are already used by somebody. Now, as you can see, if you count these free channels, so these are 9. And suppose for the video communication, we need 8 channels. But none of these 9 channels are contiguous. So basically, those are actually fragmented. And that is similar to the fragmentation problem in operating systems environment. So usual first fit and best fit techniques, so those can be applied to do this channel allocation under such an environment where we need to do this multimedia communication. But a technique has been devised by partitioning the signal in the time domain itself, so that even if you are dealing with a video signal, you can actually transmit it through different bands which are separated from each other, non-contiguous bands, and keeping the quality of the signal unchanged. So the quality of service will remain, the desired quality of service will be attained, and you can do this. And overall, this good thing is that I am not going into all these details because the time is not there. The end result is that if you use this particular technique, and if there are say 70% block channels, with IP version 4 format, we can allocate the channels in just 40 millisecond time. And with IP version 6 format, we can give the channel in 128 millisecond time. Now note that if there are 96% block channels, then with the IPv4 format, it requires only 290 millisecond time, whereas IP version 6, we can do it within 928 millisecond time, just within 1 second. But existing the first fit and best fit techniques fail altogether beyond, say, 75% block channels. So I think this is a promising state that we can also contribute to this upcoming new area where all these problems of channel allocation, problems of handoff management, problems of energy efficient communication, problems of secure communication. So we can also contribute to this area. And the idea is pretty much and very, very simple. Everybody can understand that. But for the interest of time management, I'm helping the chairman, Professor Mukherjee, and I would like to take your permission to stop here. Thank you.